Yeah, so I think I'll just do a quick intro. Uh, Hi everyone, my name is Ranraj. I'm part of the Nanonets deep learning team, and I've been training deep learning networks for the last 5 years now. And we also have Utkarsh with us here, and he heads the enterprise product at Nanonets. Yeah. So just a quick uh, takeaways. So here you'll see a fully functional document AI agent being assembled in the next 60 minutes. And we'll try to break open different components to understand them in detail, right? We'll also try to develop a mental model, right? When should we go for commercial APIs like OpenAI, Gemini, and when we should build with open source, right? And we'll also understand the common pitfalls of LLMs. Just some quick rules. Please stay on mute. You can drop your questions on the chat. We'll answer them, right? Recording will be shared. Even the code will be shared after the webinar. So you need not worry if you don't follow along, right? And you can DM for any issues. So yeah. So just for people who are not very familiar with document processing or IDP, which is intelligent document processing, what it essentially means in a nutshell is you take any unstructured document, it can be an invoice, it can be a financial document, and you extract relevant information from it. Relevant information can be uh, the key value pairs, it can be complex structures like tables, anything. Yeah. So just a quick poll so that we understand the depth of the problem we are trying to solve, right? This is an invoice right in front of you, right? It has about 25 rows and around 18 columns, right? Which adds up to about 450 cells. How much do you think it will take a human to manually type out this table, right? You'll see a poll in front of you. Feel free to answer it, right? I think I already see some answers which are quite close. 15 minutes, 30 minutes, 60 minutes, right? So as you can see, I think most of you have correctly guessed it. We ran this exercise internally, right? And it took about 35 minutes to manually type this out, right? And personally, I don't think we'd want anyone to spend their 35 minutes doing this. And even with the annotation tools that we have today, right? When you don't have to manually type this out, it still took us 10 to 12 minutes to do this. So if you were to reduce this time to under a minute, let's say 30 seconds, what we can do is we can cut manual effort by at least 90%, right? While still saving lots of money in operational costs at faster turnaround time. So just I'll take a pause here. So document processing is hard to do, right? And we have a perception that I'll just upload anything to chat GPT and it will work, right? And that does happen for the simpler use cases. We just see where it struggles right now. Okay. Let me just, I'll just go back. So what I did here is, let me just show you the document that I have. This is an invoice, right? It has all the relevant information. For example, I have the invoice date here, I have the invoice number, I have the seller details here, I have the buyer details here, this is the buyer address, this is the shipping address, and we have a couple of line items, right? And I have the invoice total at the bottom. So I uploaded this to ChatGPT. I wrote a meticulous prompt, extract all these fields for me, give me a JSON output. So if I were to check how well it did, right? Yeah. So let's just check how well it did. Let's check this field buyer address, right? I think 5th West 37th Street. If I were to look at the document, it's 9 West 57th Street, Suite 4500, New York. I think it made a lot of OCR errors here. And if I look at the invoice number, it is 915378. And if I look at the invoice number here, it messed that up also. It got 3 instead of 9. So I can see that even ChatGPT makes lots of OCR errors here, right? And I can share this with you. So as a next step, I think I tried, okay, to solve for OCR errors. Let me do one thing. Okay. Let me extract the OCR from this document and then give ChatGPT, right? So we used Google Vision as the OCR provider, and I just extracted all the words from it and I wrote the exact same prompt. Here, uh, even though I see a new problem, right? What I'm seeing here is this is the buyer address and this is the seller address. And it combined those two together into a single address. So even though it solved for those OCR errors, 57th and 4500, it suffered from something called layout blindness. So again, right, it didn't work this way also. Coming back, I'll just do a quick demo on the AI agent that we'll be assembling today. I'll upload the same document, right? Example one invoice. The document is being uploaded. Once the document is uploaded, it tries to classify the document. It has classified the document. It has asked me whether these fields are okay to extract. I'll just go ahead. It is performing the extraction right now, right? After the extraction is done, I think it will take a few seconds. Now, I think the next state is it is reviewing the extraction, the agent. Meanwhile, let's just check whether we got this right or wrong, right? Same document, buyer address 9th West 57th Street, Suite 4500, New York. I think it got this right. The invoice number is also correct, 915915. The ship to address, let's check that also. This also looks correct, 23 Grand Avenue. So it didn't suffer from layout blindness, and we also solved for OCR errors now. So this is what we'll be building today. I'll just go back. Yeah, I'll just pause here. Right. So to build this, what do we require, right? I'll quickly walk through the components that we'll need to build. Okay. We'll need an AI extractor, which does the extraction. Again, behind the scene, it will be an LLM. We'll need an AI reviewer, which will do the validations, check how confident the LLM is in its prediction. And encompassing all this, we'll have an agent orchestrator, right? It makes all the critical decisions, which LLMs to use, when to review, when to retry, when to mark it for HIL. Some common terms here, right? OCR is just optical character recognition. It helps us extract all the words from the document. This is pre-LLM technology. It's been there for quite some time. There are really good providers out there. We have OCR from Google, AWS, Azure. We have open source options as well, right? But they're not as good. Then LLMs are large language models, right? I'm sure we have used GPT-4, O3, Gemini, right? We have some open source variants here. We'll be using Qwen 2.5, right, for this workshop. Recently, Qwen also released Qwen 3, which is a reasoning model. Then we also have vision language models, right? Vision language models understand text and image both. So we have like GPT-4o, Gemini, all are inbuilt multimodal language models. We'll be using Qwen 2.5 VL for this workshop. We also have other notable LLMs out there. We have Lava. We have recently released Meta's perception model. I'll just move ahead. through some more definitions so that we are on the same page. So what is AI agent exactly, right? AI agents are systems which can orchestrate their own processes and tool usage to accomplish a task. So simply three things, right? That system has to be stateful. That is, it should have its memory, it should have access to tool usage, and it should interact with an environment. So it sounds complex, but usually the implementation is quite straightforward, even though it is used to solve quite complex tasks. There are some open source frameworks out there that uh, we use to build agentic systems. We have LangGraph from LangChain, we have Crew AI, we have Qwen agent from the Qwen team itself. I'll just pause here. We'll just check if there is any questions in the chat before we begin the bit. I think Utkarsh, if you can help me with some questions.
We don't have any questions. I think we can continue with the bit.
All right. Cool. So again, we'll share the code with you of the AI agent that we built. You needn't worry if you miss something. What we'll try to do right now is break it open, each of the component, and try to see how do we solve for such specific problems, right? What are the strategies we can use? And this is just using just open source tech out there. There is no training, nothing. Whatever is available, that is the scope, right? One second. Again, using the same document, we have the app here, right? It has different components. It has an extractor, it has a reviewer, it also has a classifier, it has an agent. Uh, we'll just go through individual components right now, and we'll share the code with you to run on your own. So again, OCR, we are using Google Vision as a provider. It is quite decent, though it does suffer from layout blindness, but at an individual word level, it is quite good. So I'll just run it. Yeah, so this is how the OCR looks like, right, from Google Vision. Next is the classifier. Again, why will an agent need a classifying tool or function, right? Again, it is to give more context to the agent if required. We can usually use a very cheaper, smaller model for this use case. The model that we be using for this is Qwen 2.57 billion, right? We just ran it. It's a basic prompt to identify the document type. It does it perfectly well. Okay. Next, we'll try to extract from this document, see what goes wrong, and how do we fix it, right? We have some basic helper functions here, part of the app. We'll be using them. So let's say I try to extract using the same LLM, which is a decoder-only LLM. I look for those relevant fields which it had, which the chat GPT had gotten wrong. I see your invoice number is right. Invoice total amount is right. Buyer address, again, it combined to buyer address. And the reason it would do so is because we are using a decoder only LLM, right? So if you think about it, a decoder can only see in one dimension. All it receives is a flat text, right? It essentially is blind in a two-dimensional space of the document, right? So it got it wrong. It combined the two addresses you see here into one, which is quite understandable and intuitive at this moment. So let's see, how do we build a reviewer to fix this or at least catch this, right, if required. So again, reviewer will try to use the same LLM, which is Qwen 2.58 billion, which is again a text-only LLM. It is trying to review the document, right? And I think it passed all the 22 fields, right? So it failed at detecting that it got two fields wrong, which makes sense on for two pointers here. One is LLMs are generally overconfident in their prediction. That is why they made that prediction in the first place. And if you ask it again for confidence, it will generally give you a very overconfident answer. And second thing is, again, we are using a text-only LLM. It is suffering from layout blindness here, so it is not able to review also, right? And even closed source LLMs are overconfident, right? Even Mistral 7B, if you try to ask it for confidence for the fields it got wrong, it will probably give you uh, a very overconfident answer. Second is let's try to uh, upgrade the reviewer for now. Let's use a multimodal model, which is again the same Qwen 2.5 vision language model 7B. Similar size, it just has a vision encoder uh, through which we can feed in uh, the image also, right? I'll just run it again, right? And okay, I'll just print out I can see it failed three fields during the review process. Buyer address and ship to address are one of them, which it correctly did so, right? So even though uh, the text LM got it wrong, the vision language reviewer was able to flag this, right? So something to think about is the reviewer needs to be a smarter or a better model than your extractor because it has to think and answer, right? Next is just building on top of that, right? It is quite intuitive that reviewing does require some second order thinking. Extraction is just first order thinking. Reviewing is trying to think, reason, and then review. So for that, we can also try a reasoning LLM, right? I think this released just a few weeks back. This is an open source model again by the Qwen team, and it is quite decent. So we tried this, right? Let's try this model. Let's see how well it performs compared to our vision language model. The only drawback here is Qwen 3 is a text LLM, right? It receives text as an input. It doesn't receive image as an input. And second caveat is reasoning models usually output a lot of tokens, so they're quite expensive to run than normal uh, decoder only or normal extractive LLMs. So there is some added cost here. So I'll just check, but it failed, right? It passed 22 fields and it was not able to correctly flag fields that it extracted incorrectly, right? And one of the reason could be that it is a text-only LLM. So I just printed out the reasoning tokens for of this LLM, right, to see if there is some scope here. So if I were to just read it out, uh, it is trying to reason whether the buyer address is correct or not, right? So it says maybe that's part of the ship to address. So it started off in the wrong direction. It was able to figure that it combined both the addresses, but it didn't reach the right conclusion. So what I want to highlight here is reasoning LLMs are not there yet, but I think they are the best candidate for a reviewer because they reason, they do second order thinking, they'll tally all your fields for you, whether the total matches all the line items or not, which you cannot expect from normal LLMs, right? And I think we'll get there soon. You can get there yourself by training a reasoning LLM. So again, the second iteration, right? We checked the extractor and we iterated on the reviewer and we improved it, right? For now, the vision language model looks like a good reviewer since it has access to both the modalities. So let's upgrade the extractor also because without it, I don't think we'll be able to extract correct output as it will suffer from layout blindness, right? So again, we upgrade the extractor as well. We'll use the same vision language 7B model, right? We'll run it through. We'll print just the relevant fields that we want to check here. As we can see, invoice number is correct, 91573. Uh, Total amount is again correct, 749, which if you remember, GPT-4 got wrong. Then I'll check the buyer address here. Let me see if it matches word by word. 9 West 57th Street, 9 West 57th Street, Suite 4500, New York 10019. I think it got it perfectly right. Let me check the ship to address, 23 Grand Avenue Shelter Island Heights, NY. Yes. So it works. So by using multimodality, we were able to tackle both by a single model, right? We were able to tackle layout blindness and we were able to tackle OCR issues. And we didn't even over engineer our OCR by formatting it into perfect layout. We let the LLM figure it out on its own, right? And that is what you would expect uh, the extractor to do moving forward, right? It will get better and better, and you can make it better by just training it. Next is we'll check the reviewer also for this, right? We are using a vision language model as an extractor. If the agent decides to review it, uh, if again, I'll use the same LLM to review, which is the vision language model. Let's see how well it does. I'll wait for it. Again, quite fast. See, again, the same thing. And we can quote many papers on it that LLMs are quite overconfident in their predictions, especially when we use the same LLM as the reviewer. So we need something smarter than the LLM itself to review its predictions and to able to do self-reflection. So again, uh, this looks correct. What I will do next is I'll try the reasoning LLM again to give it a try this time, whether it works or not. It will take some time because it will output a lot of tokens. It will try to do some self-reflection, and yeah, we'll just wait. I think it will take about 10 to 15 more seconds. But I already have the output here. So what I can see here is it failed two fields here. One is currency and one is invoice date. It says currency is not in the OCR and invoice date is in the wrong format. Again, invoice date 0806 versus 0807. If I check the document, it is in fact 0807. So it was able to correctly point out that this field was incorrectly predicted by our extractor. And if I just look at the reasoning tokens, right, invoice date, what did it think? This is what I just read it through for you guys. The OCR text mentions invoice date this in the OCR, but the invoice date that was extracted is something else. The extracted date has 806 as the invoice date. Wait, the extracted date's invoice date is this, but the OCR text shows something else. So this is a discrepancy. Therefore, this is a fail. The invoice date is extracted and the data is incorrect. So you see, right, it is able to do some self-reflection, almost like it's thinking. So there is a lot of alpha in using reasoning LLMs and building on top of it. Currently, where the industry is going is the text LLMs have gone quite better, but we still don't have good multimodal reasoning LLMs. There is one called Lava O1, but it's not quite good. And the bottleneck uh, for this is the data, right? To train a reasoning LLM, you need a lot of chain of thought data, right? How you think data. And that is very expensive to build, especially for vision language models. And it is expensive to scale also, right? And there has been some studies where we have seen the chain of thought is counterproductive and it backfires, basically degrades the quality. So one way forward is where this industry is heading is doing something called GRPO, which is training with reinforcement learning. The same algorithm you might have heard behind DeepSeek R1, right? But it is adapted for vision tasks. The main advantage of GRPO is it doesn't require pre-existing chain of thought data because the model figures it out on its own, right? You see emergent qualities where it does something called self-reflection, right? And yeah, so this is where the industry is heading. We are also working on training such visual thinkers, right? And they show very promising results. I just pause here again. Yeah.
We can take any questions right now for like 5 minutes before we go into the common problems you'll face when you try to build these agents and what you can do about. So if you have any questions, please add on chat. Ranraj, we have one question. How many lines of code has been used for the agent processing?
So again, agent processing is mostly abstracted, right? We use a lot of those frameworks. But what I recommend is since you are building for production, you shouldn't start off with those frameworks because they abstract away a lot of things until and unless you know all the abstractions, right? For example, if you need access to the logics of the LLMs, right? You need to be able to, again, go behind the abstraction and write your own implementation. Yes, yes, I'll share the code, entire code, the application also. You can run it, you can upload documents. It will be sent to you after the workshop is over.
There are a couple of questions.
Yeah. What is used as a reference for the reviewer? So again, we are building an agent at this moment, right? So the agent has to decide whether the review is correct or not, right? It has to orchestrate and it through the reviewer tool. And if it decides key this is not good enough, it will mark it for HIL, which is human in the loop. Which embedding models work best for legal and financial documents? So there are specific embedding models trained for legal documents and financial documents independently. But the newer encoders that we have, right, Siglip 2 recently released 1 month back, they work quite well. Does the reviewer take the source image and the data produced by the LLM of the OCR? Yes. To be able to review, right, it needs two things. We need the original source, ground truth, which is the image, right? We need the extracted OCR, and we also need the extracted key value pairs. Using all these three inputs, it tries to figure out whether the extracted key value pairs are correct or not. Is human interaction needed for AI agents, or would some need human intervention? Yeah, definitely. Human in the loop is part of it, especially when you're dealing with something like payments. But what helps is having a reviewer so that you know that you don't have to check 90% of the document where it is confident, and you only need to look at the 10% where my agent is not confident. So we build the agent uh, in that manner. Can we easily highlight the key value is something out of the box from the models, or is it a Nanonets feature? So what you're talking about is getting bounding boxes, right? Where it is predicted. Again, bounding box is not a solved problem. traditionally people used OCR to do back calculation, but with VLMs, like Qwen 2.5 VL8 does give bounding boxes, but it is not very accurate. So to get bounding boxes right from VLMs, you need to train the model to predict bounding boxes. And there is a lot of technicality behind it. We can, of course, go discuss it in the next webinar. But it is an entire problem on its own, getting bounding boxes right. Does the initial OCR LLM, which is the extractor LLM, and the reviewer LLM can be the same or different? Does the reviewer LLM should be of reasoning or anything specific? So again, right, what we have seen is extractor is just, I think of it as first order thinking, extraction. And reviewer has to be smarter and an upgrade. If we use the same LLM, it has turned out to be quite overconfident in its prediction, and it is not able to basically mark incorrect extractions. So it is better if you use a different LLM, especially a better one. And reasoning does help, right? Because we want to be able to tell, let's say, when the total amount doesn't match all the individual line items, right? It will require some reasoning uh, behind it.
We will move ahead. We can take one more Q&A towards the end. And a lot of the questions we just discussed, we'll try to cover them. What we have prepared is a list of common problems that you might encounter if you are dealing with document processing. Starting with hallucinations. Hallucinations is the LLM generating some text which is not present on the document. This can be problematic because business users are not used to uh, unpredictability, or they won't like random text being generated. It's more of a risk than, say, OCR errors or wrong predictions on the same document. And to eliminate it completely, what you need is you either have an AI reviewer with a very strong reasoning model, which will try to figure whether whether the extractor is hallucinating. What you also need to provide to the AI reviewer is reliable OCR text. So if you are using LLMs for OCR, that will, say, take away 5% of your accuracy in text detection. What you need is like some specialized OCR model which extracts the text, because that is more like a solved problem. OCR is like 50-year-old technology. Accuracy is much better, especially on complex documents. The other thing you can do is you can train your own LLMs with techniques like constraint decoding, which ensures that whatever output is generated is restricted to the text that is present in the document. With that, you will never get any hallucination. Like there is zero scope for hallucinations. These are like two methods which can be used to deal with hallucinations. The other problem you might encounter is too much prompt engineering. So when we are dealing with one document, like Ranraj just showed, right? The problem is easy. If there is something going wrong, you will just write some instructions and it works. Then when you start increasing the number of documents, you will encounter different templates, different patterns, weird contradictions among documents, and you might start writing rules in your prompt for that. So every time you notice a new pattern, you are writing a rule, then that will lead to very long rules in your LLM. And over time, your LLM will stop following the rules properly. If you give one rule, it will work. If you give 100 rules, it will not work. So how do you fix that? Uh, First thing is you can, if you have very long rules, right, or like a lot of rules, and some rules are applicable to some documents, then you can use another LLM to identify which rules are applicable to this file. So instead of directly jumping into extraction, first try to figure which rules are relevant to this file, and then based on those rules, do the extraction. Another thing you can do is use few shot prompting, which is, it's also known as in-context learning. So currently we are giving instructions and the LLM is giving you output based on the instructions. What you can also do is you can give an example that, so it's more like A is to B, then C is to what kind of situation. So A is to B is like an example which you give to the LLM, and LLM will figure what should be the new output for C. So instead of writing anything, you just show the example that you have already stored based on your historical data. The last thing which will help here again is to train the LLM, because when you train it, it learns all of the patterns without any prompting. The third problem that we have is no citations, traceability, bounding boxes. We got a question regarding this. If you're not familiar with what bounding boxes is, I'll just show you. So let's say this total tax is 73. Now I need to search on this invoice where that tax is. It might take you some time, but if I click, it shows me it's here. Similarly, if I click on the invoice date, it shows me it's at the top. So bounding box is the ability to tell that this value is coming from this part of the document. And as you can tell, it helps you review faster, because you can just click on it and it takes you exactly to that location. And then you know that, okay, this is where it's coming from. As Ranraj mentioned, getting bounding box directly from LLM is not possible. Even from VLMs, it's not possible. It just doesn't work. You have two options. One is you use an OCR service. OCR service will give you the bounding box for words. It will be accurate. Like there's no inaccuracy there. And you will need to do a reverse map. So if say your LLM output predicts Australia, so you need to search on the OCR, where is Australia? And wherever there is Australia, you need to find the corresponding bounding box from the OCR service. That is like one way you can do it, will solve like 70% of your problem. Solving 100% of this problem is really challenging. Only way to do it is you need to train your own VLMs to get accurate boxes. Next is misleading confidence scores. And we did discuss how the reviewer was overconfident. LLMs in general are overconfident. So they are good at generating answers that sound correct. Like that is like the way they are trained. They are not good at knowing whether those answers are actually right or wrong. And it's one of the big problems which is being researched on. What you can do to account for that is use a good reasoning LLM to review it. The next thing you can do is LLMs provide logic scores. You won't get them in like third-party APIs, but if you have your own open source LLMs, you might be able to tinker with it and get logic scores out of it, which is essentially a score associated with the prediction. It is not a proxy for confidence scores because it's not calibrated. So a logic score of 0.99 won't mean that it's 99% correct, but it will have some directional meaning. So based on those scores, you will need to add some logic and get to some variation of confidence scores. Other thing again, which the good solution to this problem is to train your own model and introduce confidence score calibration, which will tell you exactly that, okay, 0.99 means 99% correct. 0.9 means 90% correct. So that is what can be achieved, but it requires confidence score calibration. And this is again, as I said, a problem where there are no great solutions, but there is a lot of research happening. You might encounter low quality scans, scan documents, rotated, like a lot of different colors or like just unreadable stuff. If you give those documents to LLMs, most likely you will set yourself up for disappointment because they don't work that well. LLMs will work very well on like digital PDFs or very clean scans. But if you have like bad quality documents, you need to incorporate some sort of OCR model to at least get the text. Once you get the text, then the LLM can do the structuring for you. But getting the text, we would recommend you rely on specialized OCR models. If you have very difficult data, sometimes the specialized OCR models will also not work. In that case, you will need to train a VLM or there are OCR models which you can train on your data. So one example is donut OCR. So you train models like that, which will learn from your data, and that will help you. So if you're dealing with manuscripts, which were written in 18th century, then you'll need to try these things. Another issue is layout blindness. So if you are using LLMs, strictly LLMs, the LLM will deal with text. And when you give the text as input, it will miss out on features like vertical line, horizontal line, font sizes. All of that information will be lost. And that will lead to problems because when we read documents, we rely a lot on the structure, that there is a horizontal line here. So it separates the section above it and below it. Your LLM won't have access to that information. So naturally, it's going to make some mistakes. So how do you fix this? One way you can fix it is try to format your text as a markdown. This is again not like a solved problem, but there are solutions out there which will help you convert your document into markdown, which will try to retain a lot of the formatting that existed in your document. If you are able to do this step with reasonable accuracy, your downstream tasks of structuring will work much better. Another way is use VLMs. So like Ranjha showed us, use an image as well as the text as input. That will give you the highest accuracy. Last option, as you will notice, it's like the answer for everything. If you train your own VLM on your data, nothing is going to beat that accuracy. That's the way to get the highest accuracy. Another problem, if you have done a lot of prompt engineering, you might have noticed is prompt sensitivity, where your model is working fine, and you just made like a small change to the prompt, and all of a sudden a lot of things are breaking. This can happen two reasons. One is either there is some ambiguity in the prompt. When there is ambiguity, the LLM across multiple requests, it treats your instructions differently. So a quick way to fix it is take your prompt, give it to ChatGPT, tell ChatGPT to make it unambiguous, and it will figure out where is the ambiguity. It will give you a better prompt. A lot of times you won't find out. Maybe your prompt is fine. You won't find out what's wrong, and there's nothing you can do about it. The model is overfit, and like some small words are going to mess up your output. There is very little you can do in that case. Still, if you want to fix it, make your prompt unambiguous. Use system prompts. Like APIs like OpenAI support that. Those instructions are followed better. You might need to use a more powerful LLM if your prompt, like small changes, is making a difference. Or if you train your own LLMs, then you don't need that prompt. You don't need instructions. You can just give input, output, and the model will learn. You might also, like everyone who is dealing with document processing wants to generate JSON outputs or like some standard format outputs. And this was like a very big problem 2 years back. Now it's less of a problem, but when you are doing things at scale, like say processing hundreds of millions of documents, you will see that the LLM is not giving you valid JSON. Even though they have function calls or structure generation mode or all types of modes, they will exist, but still the LLM won't give you structured JSON. The solution we have figured is after the LLM gives us the JSON, we have a lot of rules in place which try to fix the JSON if it is incorrect. That takes care of like say 95% of the issues. Still 5% of the cases, among the cases which have issues, it's still like difficult to do. This problem also is solved if you train your own LLMs. So the thing to understand is ChatGPT is a general purpose LLM. It's built to give you answers on all random queries, like tell me a joke. So it will give you like one paragraph answer. What you need for document processing is an LLM which just gives you JSON output. And if you train an LLM like that LLM will never be able to tell you a joke. It will always give you a JSON output. If you do that, your parsing issues also reduce drastically. Those are all the pitfalls that we had. We have prepared this cheat sheet, which we'll share with you after the call. and we will open the session for Q&A. So please feel free to add your questions on chat and we can answer them. There is a question, what kind of training data to be used for the model? Uh, there are two kinds of training we discussed. One is, say, fine-tuning an LLM. The other is what Ranraj was talking about, which was with respect to reasoning models. So for fine-tuning an LLM, you will need data of your image, then the text of the image. So those two are your inputs, and the final output which you expect, typically JSON. So with some key value pairs, that is your output. So you will need these pairs, image plus text as input and the JSON as output. And a lot of such examples will constitute your training data. For the reasoning model, I'll let Ranraj answer that.
Yeah, for reasoning models, there are two kinds of data. Either you'll need COT, which we have been using up until now. And more recently, we started seeing techniques like we mentioned, right? GRPO, where we don't even need the reasoning data. We let the LLM do COT on its own and arrive at the final output. And just for instruction following, there is a third kind. So you'll need some RLHF data to make sure the LLM follows the instruction quite well. Because when you do SFT, right, it loses its ability uh, to be a little general purpose and understand instructions that well. This is something we have faced in production when we have fine-tuned our LLMs. So we had to also incorporate RLHF.
Uh, Open for any other questions. So is there any way to automate the data set, which is data set generation for? Yeah, so uh, you do need a lot of images. Don't try to generate synthetic images. Uh, Try to secure a data set of real high quality images. On those images, you can use a very good LLM. Use the best LLM you can find, and try to annotate that data. On that, again, try to run a reviewer. Wherever there is low confidence, get it corrected by a human annotator. Any error in your training, it will just propagate through your entire model and it will cause a lot of accuracy problems downstream. So it's fine if you have, say, lesser data, but ensure that it's fully correct. You are right, you can use like LLMs to generate that data, but you'll still need someone to do the human review. Uh, can you please share a bit about Nanonets? Yeah, sure. So Nanonets is a document processing automation company. We were founded in 2016 and process about 1 billion documents every year. Our team is based out of US, India, and UK. We have secured funding from top investors like Axel, Elevation, and Y Combinator. We have more than 2,500 licensed customers, and Our product is free to use up to a limit, and we have users who use us on a pay-as-you-go basis as well. We work with a lot of top companies like Adobe, Ryanair, and the like. And the problem we solve is document workflows and automation for any workflow, any type of document that you might encounter.
I think a question from Sharath, what is the decent number of inputs required to train your own VLM? So I think the number, Sharath, doesn't matter. There are two important things about data. One is diversity and one is quality. You can train a better model with 1,000 examples compared to a one where you train with same kind of data and more lots of annotation errors and you have 10,000 examples. So data is about diversity, and there are lots of good techniques out there for training data curation. I think the next question is about training data with respect to, yeah, it's mostly similar. There are lots of platforms out there which you can use to fine tune your LLMs. Ronnie has a question. How would you train your VLM? So yeah, Ronnie, we usually do a couple of things. You can either decide to do LoRa, right, which is low rank adaptation, or you can completely fine tune your VLM, right? And after that, the second step would be doing some kind of RLHF to make sure it still follows instruction and is still helpful in general. But yeah, I can recommend some like available frameworks which you can use right now, right? You can try uh, fine tuning it with Llama Factory is one of the famous frameworks out there, which you can try on your own.
Then there's one more question on training data generation.
Yeah. Can you share some tools or methods for high quality training data generation? There is no tools as such. We use a lot of, we have a lot of feedback loops into our product, which helps us curate a lot of good quality training data set. We use a lot of open source data set. We generate a lot of synthetic data set. Combining, we just follow two principles. Make sure we have a very diverse data set and very high quality data set. The quantity is the third priority. But yeah, there's no tools as such.
All right. I think we don't have any more questions. Thank you everyone for joining, and we will be sharing the code and the presentation and the video recording with you over email. If you have any other questions, please just reach out to us via email, and we can get into a conversation at any point of time. There is a very short feedback form that we have put on chat. We'll appreciate if you can share your feedback. And we'll just wait here for a few more minutes in case anyone wants to ask any questions. But thank you so much for joining.